Okay, so this will be on factoring. Okay, so identifying common monomial factors. So a monomial is just one number, right? Okay, so if we look at here, we have to look at the factors, okay, at the coefficients, right? Does any of our terms have anything in common, right? And here we can factor out a 2, so this becomes x plus 2. Now, how did that work? Well, when we factor out a 2, right, we have to be able to know that this 4 and this 2x, right, has a 2 multiplying by both of them. You can also verify if your factoring works is if you distribute this back in, you should get this, okay? Now let's keep on going. 3x minus 6, does any of it have a common factor? So here, yeah, 3 is in common, so we're left with x minus 2, and then you can verify that. Now, this looks a bit scary. Now we have 3 terms, right? But you might be thinking, oh, I have to factor it like the 2 parentheses like in Algebra 1. Well, look at it first. Does it have any common factor that you can take out first? And yes, it does. You have a 2 times x squared minus 2x plus 4. And really, how I'm getting this so fast is I'm thinking this times 2 should give me what I had originally, okay? So 2 times blank gives me negative 4, negative 2. 2 times blank gives me 8, which is 4. Okay. Keep on going. So 8x minus 12, we factor out here a 4. So 2x minus 3. Now, this one is a tricky one. Now, we only have 1's in front of each term, right? And so this might not, you might say it might not be factorable, but really, both of these terms have an x in them. So we can factor out an x times x plus 1. Okay, great. This side, they both have an x squared in them. And so we should get x minus 3. Here, they both have an x in them, yes, but what else do they also have in common? Also, whenever you're factoring, think of can I do more? Yes, they also have a 3 in common, so 2x plus 3. Great. Now factoring a trinomial. Now first, what you do is you look, can I factor anything from all 3, right? Are there any common factors? And in this case, no. So then what do we do? First, we put down our parentheses, okay? And we think, what times what can give me x squared, okay? And if you remember back to when we multiplied out a polynomial, this times this was always our first term. Similarly, this times this was always our last term. So that's what we're going off of. So what times what can give me x squared? Well, x and x, right? Similarly, what times what can give me 10, right? So that's why we look at the factors of 10, okay? Now, what times what can give me 10, okay? And then you think, if you look at the factors, right? How do I add them up or subtract them or whatever to get me 7? And here we have to do 2 and 5. So plus 2 and plus 5. Okay. Now let's verify that we did this correctly. So x times x, does that give me x squared? Yes. Now let's do the middle term. 2, okay, I need another color. 2 times x, that's 2x. Similarly, x times 5, that's 5x. 2x plus 5x, does that give me 7x? Yes. And we already know that 2 times 5 multiplied together gives us 10. So yes, that is the factorization. Okay, factoring in trinomial, we put down our two parentheses. What times what will give me x squared? X and x. What times what will give me negative 12? Well, let's look at the factors of just 12. 1 times 12, 2 times 6, 3 times 4. Okay? Now, if I add them, subtract them, blah blah blah, how would I get negative 1? And you think, well, it would have to be 3 and 4 because the difference between them is 1. And there's no way we're gonna add any of these up to get negative 1. So think of which one should I put a negative on? The negative on the 4 or the negative on the 3? Well, they have to add up to give me negative 1. So negative on the 4. So we can put a negative 4 here and a plus 3 here. Okay, now does this work? X times x, does that give me x squared? Yes. Negative 4 times 3, does that give me negative 12? Yes. And then negative 4, look at the numbers, negative 4 and 3, if you add them, you should get negative 1. So yes, that works. And that's our answer. Okay, factoring a perfect square. So you can either recognize this as this term is a squared, this term is plus 2ab, and this term is your b squared, or you can just factor it like normal. Okay, you just put down your two parentheses. What times what will give me x squared, x times x. What times what will give me 9? The possibilities are 1 times 9 and 3 times 3. How do we get 6 from them, right? So it should be plus 3 and plus 3. And this would be a fine answer, but sometimes you need to write it as x plus 3 squared. And so yeah, both of them are correct. Factoring the difference of two squares. Now if you remember back to the formula, a minus b times a plus b, if you FOIL that, you should get a squared minus b squared. Okay, now we're going backwards. A squared minus b squared. Our a is x and our b is 2. Right, so this should factor as x minus 2 times x plus 2. And that's our answer. Factoring a trinomial again, think of the factors of 12, 1 and 6, 1 and 12, 2 and 6, 3 and 4. How do we get 4 from these? Well, probably plus 2 minus 6. Okay? So x plus 2, x minus 6. And yeah, that works. Factoring another trinomial, we look at the factors of 8, 1 and 8, 2 and 4, and that's about it. So we have to think, how do I get negative 6? Well, from negative 4 and negative 2. So here we go, x minus 2, x minus 4. And if you verify that, that works. Now, show that x squared plus 9 is prime. So what is prime? Prime just means in this context, it means cannot be factored. Okay? Cannot be factored. And so let's try to do it. Okay? Let's look at the factors of 9. 1, 9, and 3 and 3. Okay? How do we get 0 from these factors? Well, it has to be a negative 3 and plus 3, right? But then we get the difference of squares, and if you follow this out, you would get x squared minus 9, and we need a plus 9, not 9. And so here, this cannot work. So write this as a note. Sum of squares is not factorable. Okay? So whenever you see this on your paper, okay, you know that it's not factorable. Similarly, if you see something in the form of x squared minus or plus or minus ab plus b squared, okay, this is also not factorable, but that's something for the future. Okay, now this is a challenge problem that you would see in maybe in Algebra 2. Yeah, in Algebra 2. Definitely Algebra 2 honors. Now, they want you to compute this. Okay, compute the value of this. And you won't have a calculator when you do this, okay? Now, if you do 2004 squared, okay, 2004 squared, and multiply that out, you also have to do minus this and plus that. There has to be an easier way, right? Your teacher's not going to make you multiply this out. So you look at the structure of this problem and you think, where have I seen this before, right? How do I work this into something that I do know, right? And then, right, so I'll give you a few seconds to try and find the solution to this problem. Oh, and by the way, this is, whenever there's a challenge problem, it'll always be on something you've learned in the chapter, or most of the time, right? Something you've learned into the chapter, or it has to do with something we've learned in the chapter, and we think, wait, right? Let's look at the formula for a minus b squared. That is equal to a squared minus 2ab plus b squared. Okay? Now, how does that relate to this problem? Well, if we compare, in our problem, our a is equal to 2004, and our b is equal to 2002, right? So, if we plug it back in, and right here, this is minus 2ab, right? So we can factor this actually as 2004 minus 2002 squared. Okay, now that makes it a lot easier. 2004 minus 2002, that's just 2. And you have to square that, is 4. Look how easy that is. This is also a very useful tool when you're looking at 24 squared, okay? When you do something, or here, let me write this as 21 squared, okay? When you do this, what you can do is look at this as 20 plus 1 squared, okay? Now we use our formula, a squared plus 2ab plus b squared, okay? Now, of course, you won't be doing, you won't be writing this out. You'll just be saying, oh, 20 squared, that is 400, 2 times 20 times 1, that is 40, and 1 squared is 1, and so you get your answer 441, right? And if you think 24 squared, that's 20 plus 4 squared, and then 29 squared, that's 20 plus 9 squared. You can also look at this as 30 minus 1 squared and do the difference formula. So yeah, that's just a challenge problem. Now we have to factor a trinomial when there's a number in front of x. Now really it's the same process, okay? You write down your two parentheses and you think what times what can give me, what times what can give me 2x squared, and that has to be 2x and x, okay? Now, what times what can give me 3? You have 3 and 1, okay? Now, if you put a 3 and 1 here, this requires a good number sense, right? Because we have a plus 5 right here, and to get that plus 5, we would have to do this times this, and this times this, okay? And you have to think, does that give me a 5? yes, we have a plus 5 if this is plus and plus, right? But it gets a bit challenging when there's there's more factors, right? Here, what times what can give me 2x, 2x squared, 2x and x, right? But then we look at our factors of 6 and 1, 2 and 3, right? And we think, how do I get -1? Like, let's try. If we put a plus 6 here and a -1 here, this gives me -1, but this time this gives me 12. And that does not add up to give me -1. So this requires, a developing number sense. So since -1 is very small, we might try and make something pretty small, okay? Make our factors pretty small. So what happens if, right, so 2 times something, right? So here, if we put down maybe -2 here and a +3 here, right? Maybe that'll work, right? So to verify, you just do this times this, 3, right? 3 times that, which will give me 3. This times this will give me -4. And that works. Okay. So yeah, that is our factorization. If this is too hard for you, I'll give you guys a trick, okay? One thing you can do is what you would do on the side is you would look at this equation. You would multiply your a value times your c value, okay? -x minus 12, okay? X squared minus x minus 12. And then you would just factor it as normal. So x minus 4, right? Because you look at the factors of 12, x plus 3. And now what you do is you see if you can divide any of these terms by 2 evenly. So you can divide 4 by 2 evenly. So this would become x minus 2. And then on the term that you can't divide it evenly, it becomes you put the 2 in front of the x. And that would be your factor. Similarly, if this is also too confusing for you, you can just think of the fact, right? One thing you do is you don't rewrite it. You just do a times c in your head, minus 12. And then you think of the factors of that. How could I make -1 from there? -4 and 3. And then what you do is you put your parentheses, right? But then you create, you think this times this will give me something, and this times this will give me something. And then 2x times something, that will always be even. So this will come out to -4, and then this will be 3. 2x times -4, so 2x times something equals -4. Well, this has to be in -2, and x times blank to give me 3x. Well, this also has to be a 3. So yeah, that's another way you could factor it. Okay, let's keep on going. This one's a bit challenging. If you put down your 2 parentheses, right? You 3x and x, and then you think for a long time. Well, one thing that might help you is look at this, right? And think back to the first thing we did when we were trying to factor things, right? Identifying common monomial factors. Here, before you factor, is there anything you can take out of all 3 terms? And yes, you can take out a 3. And this will make factoring a lot easier as, look, we now have something, right, where we know where this is no longer a trinomial with something in front of our a. So if we try to factor this, it's not that hard. But the problem we come into is, yes, the factors of 5 and 1. Here we would need a -5 and a +1. But the problem is this stuff, sorry, negative 5 times 1 does not give us 5. And so yeah, this doesn't work. And after you think of all of the combinations, you come up with that this piece, right here is not factorable. Okay, and so this right here is really our answer. Okay, let's see who I'm going. Here, before you factor anything, look, is there a common term from all three terms? And yes, you can pull out a 3 again. And also, not only that, you can also pull out a y. And so we get y squared minus 6y, and then minus 16. Okay. Now, can we go more? Can we go more? Yes. 3y, right? And you put down the two parentheses, y and y. This has to be minus 8 plus 2, and yeah, that works out. So this is our final factorization. Okay, x to the 4th minus 1. Now, this kind of looks like x squared minus 1, right? In which we could factor this as x minus 1 times x plus 1. But we have an x to the 4th here. So what do we do? Well, if we look at x to the 4th as x squared times x squared, right? We can look at this as x squared again, right? So really here, we should get x squared minus 1. And now we can factor it as we have something squared. Just think of this as box, right? Box squared minus another thing squared. So box minus 1 times box plus 1. Now, is that our final answer? Well, not quite, right? Here we can factor this again. So x minus 1, x plus 1, and as we said before, this is not factorable. And this is our final answer. And I just want to talk about this very briefly. When we have something like this, a power to a power, so x squared cubed, what we do is we multiply the power. So this is the same as x to 2 times 3, x to 6. And so we can also go backwards, yeah. Okay, now our x squared term is last. Normally we like it to be first. So what we can do is we can just rearrange this, okay? Plus 11x plus 5. And then, right? Okay, and then another thing we can do is right here, there's a negative in front of our x squared term. So to get rid of that, we can just factor out a negatives. So 16x squared minus 11x minus 5. Now we just factor this as normal. Okay. And here, if you try for a bunch of times, x minus 1, 16x plus 5. And yeah, after a large amount of practicing, you should be able to get this. Personally, I multiply this times this to get 16 times negative 5, 16 times negative 5, and I think, how do I get negative 11? And what I do is, here in this problem, I gave the negative to the 16, so negative 16 times 5, and then, yeah, I got, yeah, and I knew that this times this had to give me 16, yeah. Sorry, this times this had to give me negative 16, and this times this had to give me 5. Okay. So 2x squared plus kx plus 5 is factorable. Given k is an integer, find k. This is another challenge problem that, yeah, you guys can work on for a little while. Okay, so really what we have to do is we have to think like, right, if we put down our two parentheses here, and we have like a 2x and an x here, the factors of 5 are 5 and 1, right? And so if we have like a plus 5 here and a plus 1 here, if we expand this, right, this would be what would happen, what we would factor if it was 2x squared plus 5x plus 2x plus 5, right? That's what we would factor if it was like this, where k equals 7, right? Similarly, if we put down plus 1 here and plus 5 here, we would get plus x plus 10x, and then we would get k equals 11, right? So we have, right now our answer is k equals 11 or k equals 7, right? But is that all? It says that k is an integer. What is an integer? Well, an integer is kind of like a whole number, but it can also be negative, right? And so what happens here is we have to consider all cases. If we put down our two parentheses again, right? But then we put down minus 5 and minus 1, right? We would get a whole nother equation. And if you work it out, we would get k equals negative 7. Similarly, we could get k equals negative 11. So yeah. The cheat code to this is really, you can just do the first times the last, 10, and then you think of the factors of 10, right? You 1 times 10, or 2 times 5, and then you just do all of the positive cases and all of the minus cases. So at the end, you should get k equals negative 11, negative 7, 7, and 11. And yeah, that is one of the thinking problems. Okay,